Thank you. Can you hear me without the microphone, or should I use the microphone? Please. Use the microphone. I will use the microphone. It's been mentioned that I come from Hawk Mountain Sanctuary, and I want to begin this presentation by comparing some of the activities that we have managed to accomplish at Hawk Mountain and elsewhere in North America as a model, perhaps, for what I would hope will happen here in Asia. So my presentation is something of a history lesson, a brief history of raptor monitoring in North America. Then I'll talk about some of the ongoing efforts that are currently underway, very exciting things, and then offer some final thoughts and suggestions that I think may be of value. So let me start with a brief history of raptor monitoring in North America. It starts at the place I work for, Hawk Mountain Sanctuary. The sanctuary is the oldest and largest member-based raptor conservation organization in the world. This is a view from the sanctuary's principal count site, and these are the kind of birds that we are looking at. The larger bird there being a juvenile bald eagle, and the bird next to it, the tinier bird, a small accipiter, the sharp-shinned hawk. The sanctuary is located up here in eastern Pennsylvania on the eastern seaboard of the United States. It sits along the Appalachian mountain chain. It's not a very tall mountain. In fact, most people who study mountains would call it a hill. But it's the largest hill in our area. It's the only hill that tops out at about 300 meters above the local relief, so we call it a mountain. What it lacks in height, it more than makes up for in its length. This is a view. This is a view of what a raptor would see as they approach this little white spot there, which is our count site. And this this low altitude satellite photo, I don't know how many of you can see it, but there's a gray line right there. That is the Kittatinny Ridge, 300 kilometers long. It runs from the northeast to the southwest. The principal winds in this part of the world come out of the northwest here, and they have to rise up and over that ridge. That in turn creates what we call a leading line for raptors. It concentrates the birds as they come up and over the ridge, take advantage of the updrafts, and are attracted to and adhere to the ridge from anywhere from several kilometers to dozens of kilometers, or even 100 kilometers. This allows us then to see large number of species. I think here the number is 28 or 29 species. We have only 16. These are 6 of them. This is an osprey, the only one we have in common with you, a small buteo, a larger buteo, a harrier, a small falcon, the merlin, and then a small accipiter striatus, the sharp-shinned hawk. The compressing effect, the leading line effect of the Kittatinny Ridge brings the birds in very close, which makes them spectacular to look at. It not only brings single birds in close, it also brings large groups of birds. So when you get this kind of a phenomenon, these secretive birds showing up very close, showing up in large numbers, you get bird watchers. They come in, it's great. The birds do all the work. They fly past the bird watchers. The bird watchers just have to walk up to the observation point and sit down and begin to take in the scene. We use that for all kinds of education purposes. We can use several live birds to show children and adults up close what raptors look like. We can use volunteers and staff to help identify the birds as they fly by, and we can use volunteer educators to help educate school children when they come to Hawk Mountain. It's a wonderful story, but that's not the way it was before Hawk Mountain was founded in 1934, because then when people came, they weren't bringing binoculars, they were bringing shotguns. They were coming to shoot and kill the birds, not to watch the birds. There was a $5 bounty, this is in the 1930s, some time ago, on northern goshawks at the time, and people would bring their guns, they'd bring their children. I don't know how many of you can see it, but this little boy right here has his right arm around a double-barreled shotgun right down there. And many of the hunters would bring 2 or 3 guns because the barrels would get so hot from them firing, and so often that they had to put them down and use another gun. All of that came to a screeching stop in 1934 when this woman, Rosalie Edge, hired this gentleman, and he brought along his wife. This is Maurice Brune and Irma Brune here, and a sanctuary was born. And instead of shooting the birds, we began to watch the birds, and equally importantly, we began to count the birds. So today we bring in lots of visitors, especially on weekends, and equally importantly, we bring in lots of school children. Here you see a group of school children learning how to use binoculars. This is very important for us to bring the birds as close as possible to the minds and eventually the hearts of the school children. We also have been attracting conservationists for a very long time. This photograph was taken more than half a century ago in the late 1940s, and the woman behind the binocular is one of the most famous conservationists of the last century. This is Rachel Carson, who wrote a book, Silent Spring, that set the stage for a better understanding of how raptors were being affected by the misuse of DDT and other environmental contaminants. So in 1962, she published this book. By 1967, we had figured out what the problem was, that DDT was reducing the eggshell's thickness of the eggs of birds like peregrine falcons and bald eagles, and when the parents were trying to incubate the eggs, the eggshells were being crushed and the embryo was being destroyed. Bald eagles and the counts of bald eagles at Hawk Mountain played an important role in Rachel Carson making the case for the relationship between the misuse of DDT and declining populations of raptors. We had been counting bald eagles and noting whether they were adults or juveniles at the sanctuary since 1934. That's about 8 years before the widespread use of DDT began to occur in North America following the Second World War. So we had counts that Rachel Carson could use to make her case. We had a counter who was talking about warning all the way back in 1952, the eagles. In the mid-30s, it was usual for us to see as many first-year birds as adults. In recent years, the ratio of immature birds to adults has shown a steady, disturbing decline. And again, in 1959, without knowing why we were seeing this, we were recording it in a way that allowed scientists then to use it as evidence for a population effect, a negative effect of DDT and other organochlorine pesticides on birds of prey. This is what the data look like. These are the ratios of juveniles to adults. So that drops off right at the beginning of the DDT era. And it stays low until right after the DDT era, and it starts coming back up. Interestingly enough, the actual numbers of birds didn't decline until about 10 years into the DDT era. So by taking this second bit of demographic information, adults to juveniles, we were able to detect an impact almost from the beginning. The data were also used in the late 1960s to document the correlation between DDT misuse and declines in peregrine falcons in eastern North America. And in fact, beginning in 1969 through about 1990, a number of papers were produced that used the data, the count data from Hawk Mountain to document population shifts and eventually recovery from DDT effects once DDT had stopped being used in the early 1970s. I could go on. I've been working at Hawk Mountain Sanctuary for 20 years, so I could fill the rest of my 50 minutes with talk of Hawk Mountain. But that's not really the important thing. It's what Hawk Mountain started and what I think Trufan will do here as well, and that is to incite others to participate in this endeavor of monitoring the movements of raptors. This is what the map looked like in terms of monitoring sites in 1935. 2 sites, Hawk Mountain and Cape May, New Jersey. We flash forward to 1965, and now we have dozens of sites, mainly in the northeast of the United States. Move forward another 20 years, and now the sites are spread into Canada and into the western United States. It's like an infection, a good infection on the continent. The growth in monitoring continued in 1995. We had a site down here in Mexico. I'll get back to that site in just a minute. And by 2010, we've had a number of sites in Central America and South America on the island of Cuba, and more sites up here. This has allowed us to compare counts from multiple sites. All of these sites are important. Some of the sites are a wee bit more important than others. This is the ground that you're looking at on which the counters count birds in Veracruz, Mexico. Veracruz, Mexico is this site right down here. North America is sort of like a large funnel, and most of the flight of 3 species of migratory birds comes right through Veracruz. If you look on the ground, it's not much to look at. Olmecs and Toltecs and Aztecs and Mayans have been using this land. More recently, European settlers have been using it. But when you look at the end of the binoculars here, you see large numbers of birds. This happens to be a very small portion of a very large flock of turkey vultures. These are some numbers that are truly astounding here. Okay? Turkey vultures, 1 million. Broad-winged hawks, 929,000. Swainson's hawks, close to 500,000. All raptors. This was the first year, and I can tell you, at the first year of a count always undercounts the numbers. The second year they counted close to 5 million, and they've averaged 5 to 6 million. 5 to 6 million birds of prey a year. Over 2.5 million turkey vultures coming through. And of course, a lot of education going on as well. This is a former intern at Hawk Mountain, educating the next generation of Mexicans about their biological heritage. Other sites are equally oversized. The site in Costa Rica, in the southern Mesoamerican land corridor, is especially near and dear to me. It's peopled, it's run by indigenous peoples, the Bribri Indians who live in Panama and Costa Rica. This is a mother and son. This is Kira. He was, I think he was 4 years old when I took this picture. He's a teenager now. He's got the most incredible eyes of any hawk watcher I've ever met. The first day I was out in the field with him, he was standing next to me. He knows the names of all of the raptors in 3 languages, plus their binomial name. And he pulls on my shirt and he says, he points up, doesn't have binoculars with him. He points up and he says, "Osprey, osprey." So I look, I don't see anything. I put my binoculars up, and I don't see anything. I put my binoculars down. He pulls on my shirt again. Osprey, osprey. So I look again, and way off in the distance is this tiny speck. And about 10 seconds later, I could recognize it as an osprey. So I turned to the counter and I said, Kira's right, there's an osprey out there. And then he pulls on my shirt again. He says, osprey, osprey. He doesn't know the word to, okay, in English. So I put the binoculars up again, and now there's a second speck way behind the first speck. This is an official counter right now. He wasn't the official counter. He was just a spotter back in 2000 when I took this photo. That's the kind of activity and enthusiasm you can engender in communities. The other neat thing about working in the tropics is that the birds do not behave the same way in the tropics, and I'm talking about the same birds as they do in Europe and in the northeastern United States, where all of the ground rules for raptor migration were laid down. So, for example, this is a site at 10 degrees north latitude in Costa Rica. Well, these guys, I don't know if you can see them, but they're little pepper specks up here, and they're flying over water here. Every morning, before the sun manages to warm the land and create thermals, land-based thermals, there are thermals that are occurring over the near coastal waters. I can tell you later how they occur. These birds get up at dawn and go out and begin to migrate at 6 o'clock in the morning. These are soaring migrants, and they are soaring in this image here. They also soar when it's raining out. This picture was taken during an afternoon when there was steady rain and there was a flight of 15,000 turkey vultures came through. So wonderful things that we can learn from tropical sites as opposed to temperate zone sites. A number of studies have occurred recently that have used multiple sites. These are the data. I want to show you the data in a more appealing fashion to give you an idea of how these data can be used together. So let me talk about some of the recent and ongoing efforts that we're doing in the field, including what we call the Raptor Population Index, which I think is a way forward for people here in Asia to proceed. We're developing and maintaining a continental-wide raptor migration count databases on a site-by-site basis, determining population trends and assessing the conservation status of North America's raptors, and broadly disseminating the results of our analyses. It took us a long time, a lot longer than it's taken you to get to where you are today. We had an organizational meeting in Syracuse, New York in 1974, the creation of an organization very similar to ARRCN. In 1975, the creation of Hawkwatch International, a Western United States-based organization in '84, development of a website that places all of the data out there in 2002, and the creation of the Raptor Population Index, which is a statistical method for determining whether populations are increasing or decreasing. The essential elements, and I think these are very similar to what is happening here. This is a citizen-based project. Dozens of independent watch sites are working together in partnership with a number of organizations, Hawk Mountain, Hawkwatch International, Humana, and the Bird Studies Canada. The use of common field protocols, so the results are comparable from one site to the other. Online data entry and the use of common statistical protocols. I won't go into the details of the analysis, but we have a 466-page book that details how we go about our analyses and what the results are through 2008. Basically, what we think we are doing, what we hope we are doing, what I believe we are doing, is to monitor populations at different sites. Sometimes they're overlapping, sometimes they're not, and figuring out whether populations are increasing or decreasing or remaining relatively stable. These are some of the sites that we've analyzed thoroughly in the eastern United States. These are some of the sites that we've analyzed statistically in the western United States. And these are the data, and these are, I think, in a more palatable and understandable format. Look at this. This is Cape May, New Jersey, down here in Hawk Mountain. I'll run through several different species. This is peregrine falcons. Cape May hadn't started as early as we have, so the tail over here isn't available for analysis down here. But look at how similar they are. That's relatively remarkable. It gets better. Different angle here, a slight decline in the red-shouldered hawk, again in both of these sites. So this is the power. When you start doing this, you start being able to convince people that species are increasing, species are decreasing. Oops. These are northern harriers, and again, remarkable similarity. Not all of them are perfectly similar, of course. This is the Cooper's hawk, which shows a downturn of late at Cape May, but not at Hawk Mountain, but an increase over time. And then decreases in American kestrels at both sites. Coincidental, by the way, with the increases in Cooper's hawks, and I'll talk about that a little bit more later. This is just a correlation showing you how the orange line would be perfectly correlated between the two sites. And the dots show that we have a relatively high level of correlation up here between counts at one site and counts at the other site. Now, when you start looking at more sites, like take for example this 8 sites in eastern North America, looking at peregrine falcon numbers, you see again remarkable congruence here. None of these lines are significant, but they all show an upward trend, which makes us believe that eastern North American populations of peregrines are indeed increasing. Now you do run into problems when birds have a tendency to flock on migration. You get great variability in trends among sites. So these are broad-winged hawks right here. This is what the bird looks like when it's taking a break on its migration journey. And unfortunately, this is like spaghetti right here. This is what the correlations look like, and all those asterisks mean those are actually significant changes at those different sites. They're just in all different directions. So we have to be careful, and I'll talk about how we can take care to do a good job in using the analysis. This is the book I mentioned. I have a copy with me. I'd be happy to share it with people. It really is our Bible, and I certainly intend to leave the copy that I brought here in Thailand. These are the kinds of figures we can put together. Notice all of the down arrows here for American kestrels. We believe that what's going on, and we know this from some telemetry work where we actually followed individual kestrels and looked at mortality factors, that kestrels are actually falling prey to the Cooper's hawk, an accipiter, which is increasing. So as the Cooper's hawks go up, the numbers of kestrels are going down, and we believe that that's a causative relationship. Some species are doing really well. Bald eagles are going up. Other species, like turkey vultures, also are going up. Look at the number down here, 2 million. So they're all coming through here. Now the question is, where are they going in South America, and are they getting into trouble there? Well, to answer that question, we have to start putting lines, imaginary and otherwise, on a map to try and figure out where these birds are going. Most of these lines actually are representative of what the birds are doing. And we know that because we've been studying migration connectivity in this species. Migration connectivity, simply put, is understanding where the birds are coming from that you're counting at your watch site, understanding where they are going to. Because if they're having problems in either of those areas, you may see those problems reflected in declining populations, but you won't know if it's problems to the north or problems to the south. So what we've been using, and it gets really expensive really quickly, is satellite tracking for turkey vultures. We've put satellite tracking devices, 30 of them, on turkey vultures in the eastern United States, the western United States, at the northern limits of their range, in North America, and I don't know if you can see it down here, but in Argentina as well. This is a breakdown of the 30 units that we put on. We're putting additional units on if all is going well. In Pennsylvania right now, 2 birds are being telemetred this week or next. And this is what we can build up. All of these dots represent fixes that we've gotten from a number of birds that were telemetered on the breeding season up here, or up here. Look at the differences in the migration corridor. So we have considerable connectivity that we've been able to show. On the East Coast, the birds go to Disney World. In central Canada, the birds go all the way down to northern Venezuela in a rather small area. The birds from the western United States that are breeding in Washington State and Oregon go down into Mexico and as far south as Guatemala. So we've got considerable connectivity. What this means is if we start seeing changes in the populations, we know where the birds live, so we can start looking in those areas for reasons for the changes. And we've done this also in Argentina. I love this slide. I love this slide because, whoops, I didn't love it that much. What happened there? Okay, that's it. Bye. Sorry, I won't use that word again. It's a connection problem, isn't it? Okay. The next is an outlier. That's noise in the system. That noise in the system is what is the raw material for natural selection, and we think that that bird is every bit as important as those others that show this guy over there. I have a quick series of slides that I want to show you that show how precise these migrants can actually be, if we can get that working. If not, I'll tell you what the slides say. They show that birds that breed in a okay. Perfect. Okay, so this is noise in the system, but it's also the kind of noise that's good noise for biological entities, because if things go wrong over here, where these birds are currently going on a regular basis, but they don't go wrong over here, a new population could spring up there. So this is what I like to think of as evolution in action. Okay, this is the power of this technique. This is an outbound migration of one bird in autumn of 2007. He goes back, okay? He comes back the next winter. He goes back. He comes back. You see where he's winding up? Right in the same tree. We went down and checked this bird out. We actually found him in the tree that he was roosting in. He spends more time in Venezuela than he does in Canada. So really, he's a Venezolano bird who just happens to have a house in Canada. But I mean, just look at this. Now, that cost us about $7,500. Those last slides, $3,000 for the unit, and then about $4,500 for the data downloads. That doesn't include our time in the field. That's just for the equipment. So it adds up really quickly, but the data add up very quickly too. And this is extremely. Oops, there he is again. Another technique that we use that also works really well is a lot cheaper. Each one of these units cost about $10. There are 7. This is not Photoshop. There are 7. There are 7 birds there. And why is this guy smiling? He's a former intern at Hawk Mountain Sanctuary. He's happy because these 7 represent only about 10% of the birds that he caught all day. He caught over 75 birds. that day. These birds were caught in Venezuela and then were tagged. We knew they were migrants based on the subspecies, and we knew that they were going to migrate back into North America. We didn't know where, but we've put more than 450 of these tags on these birds, and using the power of North American bird watching, which is very site-specific, we were able to capture the locations of 38 of these birds. So it's really remarkable. Okay, final thoughts and selections. I'll move through this quickly. Raptor monitoring at watch sites, the kind of thing that's happening now across Asia. When used in association with data from other bird monitoring programs and from wing tagging and satellite tracking studies, is a useful tool in assessing population status of birds on a continental basis. You got to think about geography. We know that there are two major corridors here. Those would be the places to start. I wouldn't worry too much about the magnitude of the flight. You do want to capture the bulk of the flight, but there are going to be small sites, small in the sense of numerically small, that are going to offer you important information for trend analysis. You have to work with the willing. You can't force people to do this, but the more people that get together and show a product, the more likely some of the naysayers will be to come along. Work with what you have, and then of course talk about and publish the multi-site results. RPI, the Raptor Population Index, is a collective impact initiative with a backbone organization, Hawk Mountain Sanctuary. It's a contingent fact of history, which says its history is unique. Don't expect to have the same kind of history here, but it's important to have it. It's really getting places. Bildstein's paradox of fundraising. This is simply put that the bigger the project, the more likely you are to be able to successfully fundraise for it. It sounds paradoxical, but it has been true at Hawk Mountain Sanctuary. When we've thought big, when we've asked for money to buy 30 satellite tracking units instead of 3, it's turned out to be easier. In North America, I don't know, maybe there's something in the water or something like that, but it certainly works. And having said that, if all of it was easy to do, it would have been done long ago. So don't expect it to be terribly easy. We still have I love these pictures. These are beautiful photographs, but there's a story behind them. These pictures were taken in 2006 on the 16th of November. That was the day after we stopped our official count at this site. This is at the Panama Canal. And we knew that by the 15th of November, there wouldn't be any more migration. But we forgot to take the pictures. So we thought, well, let's go up on the 16th. We'll take some pictures and at least we'll document what we've been doing. On that day, 660,000 turkey vultures migrated through. The biggest day. So then we had to shift our full season count by 15 days. So we're still learning. And there are going to be surprises. There will always be surprises. I'll stop there, offer a big thank you, and challenge anyone to tell me where this photo was taken, who hasn't seen it before, and what the species is. It's a raptor with the shortest migration distance of any raptor I know, about 8 miles, give or take, a couple hundred yards. It's a photograph from the Islas Malvinas, from the Falkland Islands, and those are striated caracaras. But that's a story for another day. Do I have time for some questions? Thank you very much. Anyone have any questions?
You mentioned thermals occurring near coastal waters. How does that happen?
Yeah, that happens when during the night you get cold air being formed over the land because of back radiation to the nighttime sky. That cold air is dense, so it rolls off of the mountains and it shoots out into the shallow waters of, in this case, the Caribbean Sea. Those waters have a lot of latent heat, So they are warmer. The water is warmer than the air above it. Whenever you have a surface that is warmer than the air above it, you get conduction and you get thermals forming. So these birds purposefully, not only do they cross water, they purposefully fly out within maybe 200 to 500 meters of the coast, and they take advantage of this, and they get about 2 hours more flight time every day doing that. All right,
Looking at your maps of North American monitoring sites, I looked in vain for Cedar Grove, the role of Cedar Grove in all this kind of thing. Is it a monitoring site as well?
Yeah, it is. It's a monitoring. Well, it's a banding site.
Okay.
And Helmut Mueller did not want us to put it on the map because he doesn't want visitors coming there. It's an academic site, and I don't know if you know Helmut, but he's very Germanic. Helmut Mueller, and I like him a lot, but when he says no, that's why we didn't put it on. It's a very important banding site, remarkably important, but he doesn't want any visitors there.
I was interested because I took Helmut, birding in Thailand about 10 years ago.
He's a great guy.
He's a great guy. Yeah. So it must be getting on that.
Yeah.
Still going.
Yeah.
Good.
How long does the battery on the bird can?
Good idea. Good question. When we first started off, they didn't have solar power batteries. Now our batteries will last. We have that one bird 8 years with solar power. We didn't have GPS when we started either. So the original batteries, to get back to your question, lasted about 2.5 to 3 years for us. If you talk with other people, we've been very lucky. We use a bird that stays out of really bad weather. We have a bird that stays in open habitats for the most part, so it recharges batteries and it doesn't damage the units in any way. It's a very passive bird with regard to, so it's worked out very well for us. Now we're going to a third generation unit, which is a GPS unit attached to a GSM card, a mobile phone card, and now those units only cost $1,500, and the downloads come through the mobile phone connection, so they're less expensive. So we're testing those. We're in the testing stage. We haven't put them on. We're going to put a couple of those.
So now you said the solar cell?
Yeah, we're using solar-powered units. Those are big units. When we started out, they weighed, the first units we put on weighed 60 grams. Then we managed to put them down to 35 grams and still get good power and everything. But when you're talking about Chinese sparrowhawks or something, we're looking at a 5-gram unit, and those are still, I would say, in the experimental stage, in the iffy stage. Yeah, but that's where these 60-gram units were when we started using them in 2003. Yes.
You mentioned that the raptors, when they migrate from the north to Mexico, that they behave differently, they change their behavior. Can you give us an example?
Yeah, I'll give you a very good example. They start earlier in the morning. Those turkey vultures are migrating right at sunrise because they can go out over those waters, those warmed waters, and receive those overwater thermals. But we've also documented changes in the flight behavior of broad-winged hawks. We looked at broadwings in flocks in Pennsylvania and recorded how many flaps they were engaging in when they were soaring and gliding. And then the same birds, literally, in Costa Rica were looked at, same observers, and we found out that the thermals are stronger in Costa Rica, and the flapping rates during soaring are significantly less as well. So I think almost everything we have that's in the textbooks about raptor migration is based on studies that were conducted in Europe and studies conducted in North America in the temperate zone. And I think they're very representative of those two areas. But all bets are off when you're talking about even the same species. I mean, there are general guidelines, but I don't think the birds are following strict rules.
Thank you very much. I have